Good morning all of you, and let's try this sum. And as you can clearly see, this sum is limit n tends to infinity sigma of something k by n. So as k changes, so if I'll decode this, k equal to 0 will give first term 0, k equals 1 will give 1 by n root over 2 by n minus root over 1 by n plus 2 by n the root of 3 by n minus root 2 by n plus 3 by n under root of 4 by n minus root 3 by n, and so on and so forth. So where the second last term will be n minus 1 by n root over n by n minus root over n minus 1 by n, and the last term is n by n, which is 1 root over n plus 1 by n minus root n by n. And we need to evaluate limit n tends to infinity. Now one straightforward way of evaluating limits is to use algebraic manipulations, but here unfortunately these things are not algebraically very simple to manipulate. So the idea is we can use Riemann sum, and the essence of Riemann sums is if somehow we can convert this into area of bounded figure, then that area will represent the summation of this series. So here we go. Now the major problem with this problem is we need to appreciate what is the significance of 1 by n, 2 by n, 3 by n, and so on till root n by n, as well as what does this signifies. Okay, so it's distance between like b minus a, d minus c, f minus e, and so on and so forth. So here either we have taken, so there are two possibilities to think. Maybe someone has taken an interval of length 1 and he has divided it in n equal parts. So that is first thought process, where these parts are 1 by n, 2 by n, 3 by n, and so on and so forth till n by n. So this represents the length of this rectangular width, and the height should be represented by root over 2 by n minus root 1 by n. Similarly, height should be represented by root over 3 by n minus root 2 by n. And it feels at least a little bit challenging to think for a height, like where the area of rectangle can be thought in this way, because basically we need to find a function which maps all these heights. So that thought process is not clear over here. So I'll take a reverse engineering here. So what we're going to do is, instead of dividing interval to 1 by n, 2 by n, which is our usual procedure, I'll divide interval with this partitioning. So now the other thought process will be, instead of that, you can take 0, root 1 by n, root 2 by n, and that motivation is quite clear because this gappings is what exactly is appearing in those limit sums, right? So these gappings is precisely what we are interested in as length into width motivation. So last will be n minus 1 by n times root over n over. Now what exactly 1 by n, 2 by n, 3 by n represents? So that's not very difficult, because corresponding to this I need a height of 1 by n, corresponding to this 2 by n, corresponding to this 3 by n. So it is basically a square of this. So we are going to get a function y equal to x square. So if I'll consider a function f of x equal to x square, and here of course I'm interested in 0 to 1 interval. Okay, so for this function graph will look something like this. And now I can decode these values. So 1 by n represents this height, and the width, the distance of root 2 by n minus 1 by n is this small area of rectangle. Similarly, root 2 by n, corresponding to that I'll get a height of 2 by n, and we'll have this rectangle that represents second term, right? So this is length into breadth. In the same fashion, we can repeat this, and you can see the third segment will have 3 by n as the height, and the gapping is root over 4 by n minus root 3 by n. So if we'll keep on doing this, we can roughly make this diagram till root over n minus 1 by n, root over n by n, right? So that will be our last term. Now you might notice, what about this last term that we are having? Okay, so I'm adding limit n tends to infinity up to this term and plus this extra term, because that extra term will have a significance when we'll have root over n minus n means this gap, right, with n plus 1 minus n by n. So that will have an extra height which is going away from the window, so we need to add actually this extra height according to the proper description of question. Now this height is already finite because it's just one single height, so I'll separately find this quantity. N tends to infinity, you can see it's anyway 1, so that quantity goes to 1 by n minus root over n by n. Since n is infinity, so this sum is finite, 1 minus 1, so 0. So the last term can simply be discarded, because if and only if the remaining sum is finite according to limit theorem. So limit x tends to a, f plus g can be written as limit x tends to a, f plus limit x tends to a g, if and only if this both limit exists and is finite. So here, if I can give guarantee this entire sum up to n minus 1 by n exists, then I can ignore this. And that existence is guaranteed from the Riemann sum over here, because now I can clearly see what about this summation. Right? So this summation is nothing but area of the first rectangle, which is 0, area of second rectangle, third rectangle, and so on and so forth. So it is 0 to 1 x square dx integral. This will happen if I'll take limit n tends to infinity, because when n is tending to infinity, then these intervals will still be shortened, so we'll have more and more chunks here, and hence the accuracy of our result will increase, and it's always possible to increase the accuracy. So hence the answer for this problem is x cubed by 3 and 0 1, which goes to 1 by 3. Now some of you might ask the question, like instead of neglecting this area, if someone can think directly from the upper Riemann sum, still it can be done. So let's apply the same thing, 0 root 1 by n, root 2 by n, and we have root over n minus 1 by n, root n by n. Now instead of taking the lower Riemann sum, you take upper Riemann sum, in the sense, like now first quantity I can notice its difference of root 2 by n minus root 1 by n times 1 by n, right? Now there can be another way of doing this, the way you used to do Riemann sums for your JEE preparation in your coaching institute is, usually you will replace k by n with x and 1 by n with dx. Why you are doing so is already explaining method 1, so that's the logic for this. But here unfortunately blindly I'll do, so I'll get sigma k by n root over k minus 1 by n k plus 1 over n minus root over k by n. K is going from 1 to n, limit n tends to infinity. K is going to 1 to n minus 1, right? So in the first method I have shown, this extra part came because I have taken k equal to 1 to n, right? So instead of n minus 1. Actually that did not change the answer, and that was another subtle point which I wanted to tell you. So instead of this n minus 1, if someone would have taken n, still the answer will still converge to 1 by 3. Okay, if it is up to n minus 1, then this part will not come, so automatically we'll have all this area. So anyway, that also converges to 1 by 3. Now blindly if we'll apply this, you'll be tempted to get wrong answer first. Misconception will be replace this with x, and here you will have root over x, because k by n plus 1 by n, and you'll assume n tends to infinity, 1 by n tends to 0, so this is minus root of x, and then we'll do integration from 0 to 1. But the problem is this is wrong because you have not used dx anywhere, right? So to invite dx, we need to multiply and divide by n. So this part I can tell it behaves like x dx, right? But what about this part? This part is still like it's x minus x, so it gives you nothing. So 0 to 1 integral, this is giving you answer at 0, which is again clearly wrong. Okay, so how to manage this? You can't directly replace it, we have to replace by manipulations. What we can do is we can rationalize that term, root over k plus 1 minus root k by root n. And now if I'll rationalize, so I'll multiply with k plus 1 plus root k over root over k plus 1 plus root k, and this quantity simply goes to 1, and now we have sigma k equal to 1 to n minus 1, right? And now you can see, like when k is running from 1 to n minus 1, this quantity will run, right? So the given expression will be k by n times root over k plus 1 plus root k, this summation k running from 1 to n minus 1. Right, now what to do about this? Again, if we need to invite k by n everywhere, this we can't reduce with 2 root k, right? Because k is also going to finite, all the limit n tends to infinity. So because of that finiteness, there is no way in which you can again reduce this to, let's say, k by n times. Someone will tell k is also going to finite because when n is too much, so that's going to be 2n root k. Now if someone can do this question in a completely wrong way, and where they'll give the argument k is infinity, so it's very large, so let's replace with this as 2 root k. Fine, and this summation k is going to 0 to n minus 1, and limit n tends to infinity. So now finally we have 1 by n times 2 root over k by n, and this summation goes from 0 to infinite, which reduces this to half integral of 0 to 1 x root x, which reduces this to half integral 0 to 1 root x dx, and that gives you still 1 by 3 as the answer, right? But this is a wrong way of solving this question. It's conceptually wrong. So you put it in the comment section if you can do it exactly in the way as your coaching institute asks you to do by replacing this blindly. But remember, like sometimes you can be trapped. The another way of possibly doing this question is, in the interval 0 to 1, I can define a new function g of x as root x. Right? So I can define root x from 0 to 1 to 0 to 1 as a new function g, which is precisely inverse of the given function f of x. And now I can realize, instead of making the partitioning root over 1 by n root over 2 by n, I can make a partitioning 1 by n 2 by n along y-axis, and corresponding to this we'll take the reflection about y equal to x to find the answers. So that can also be done exactly in the same way. So I hope you got the logic, the mechanics of Riemann sum, and why exactly that engineering of replacement works. Thank you. Have a good day. Stay tuned. Please do like and subscribe.